Mm-hmm.
which then becomes 3 over 9.
And what?
And that becomes 1 over 1 over 3.
And yes, what is 5/5?
1.
So you can divide first and simplify. And multiply second. Might make it easier.
So you can just make it 1 over 9 and 3 over 1, or just 3.
And so I can simplify. You get the same answer, but you can
Yeah.
divide first. So anyway, you can do that for part B.
It'd become like a 1 over b times c over times c.
Yeah. And so
So
what is
like ac over b.
it? 1c over b. Just c over b. That a became 1.
Oh, so it's just c over b.
And an idea about question C.
Can the x's cancel out?
They have plus or minus between them.
Okay.
You need. You can only cancel if they have times or divide. Let me do C part 1. Factorize x squared minus 1.
That can just become 2x.
No. It is the same as. Well, it's a difference of 2 squares. Or another way to look at it is x squared plus 0x minus 1.
So can we just solve it in the calculator?
Yes. You get x equals 1 or x equals minus 1.
Okay.
And so factorize that.
X minus 1 and x plus 1.
Yeah. Okay, how do we do C part 2? This one up here.
The one on the left.
The original one.
Okay. So we have like the fraction on the right is like 3 over, and then the factorize, the answer for the factorize we got.
Yeah, so x, another way to write x squared minus 1 is x plus 1, x minus 1. What do you do then?
What do you mean by it can be written like x plus 1, x minus 1?
You know how you factorized x squared minus 1?
Yep.
So that's the same as x minus 1, x plus 1 in factorized form.
Yep.
And so anything you can simplify?
Or can you cancel out the x on the right, the positive x's?
They have plus or minus between them. You can only multiply things that have times or divide between them.
But the x plus 1 and the other x plus 1 have a multiplier in between them, don't they?
Correct.
Yeah.
And so what is your answer?
A half times 3 over x plus x minus 1.
All right, multiply them.
You get 3 over x 2 multiplied by x minus 1, and would it be also be 2 multiplied by, and I just want that one, isn't it, because I don't want to cancel out.
Yeah, that's it. I mean, you could expand the bottom, but it's probably best not to in case it factorizes with something on the top. Yeah, so big picture is multiplying and dividing are the opposite of each other.
Yep.
Doesn't matter what order you do them in. Doesn't affect BIDMAS. In general, you want to
Yep.
divide first because it makes the number smaller.
Yep.
If they don't have time to divide between them, make them have time to divide between them. Fully factorize, fully simplify.
Yep.
Let me see. So that's multiplying. All right. How do we do? Maybe it's all good. Might as well.
Yep.
All right. How do we divide fractions?
Which one? Question A or B?
In general, we'll start with A.
Oh, just in general. For like algebraic fractions.
Any fractions, how do you divide?
Multiply the top. And then you just cancel out if there's like, say if there's like one fraction, like one of them's on the same number on the top and another fraction, same number on the bottom, you can cancel them out.
Keep change.
No, keep change for yeah.
A.
It becomes A over B times C over A.
Yeah.
And then that becomes 1 over B times C.
What do you
Which
get?
becomes C over B.
That's it. All right. Question B.
So you make it times 3x, no, x squared minus 16 over 3x plus 6.
Okay. Next.
And then you want to make the top x minus 16, x plus 16.
Square root of 16.
Oh, 4. So x plus 4, x minus 4.
Yeah. What about the bottom? Can you factorize that?
Factorize that 3, so you get. Yeah, so you make it 3 brackets x plus 2.
All right. What can we do?
The x plus 2 cancels out, so it'd just be over 3.
Anything else?
The x plus 4s cancel out,
Well done. And so
so you get x minus 4 over 3.
x minus 4 over 3. That's great. There we go. Let's see. I like the look of the last one. Yeah, how about that last one? F.
So you make it multiplied by r cubed over 4.
Yeah, and then
Could you factorize the one on the left, top left?
no. Anything you can cancel?
Oh, the r squared, like squared and the cubed, right?
That would be if it was on the bottom. They're both on the top.
You can cancel out the 2 multiplied by the r.
You have 2 on the top. You have 4 on the bottom.
So can we just multiply them together? Would that just work? Easy if we just multiplied them.
It will, but what's 2 over 4?
A half.
Yeah. And if you multiply them together, it would simplify down to that anyway. So what do you get? When you multiply?
You get 2v squared over 5, and then times v cubed over 2. Oh, not v, sorry, r squared, r cubed.
All right, multiply.
You get r to the power of 5.
Yeah.
Over 10.
That's it. That is it. Let's see. If it's necessary. It's more the same, I think. Let's see this. All right. Let's do question A. Any idea about that?
So you keep change flip first.
Yeah, and then
And solve the top one as a quadratic to make it easier.
yeah. What do you think one of the brackets is going to be? Or what would
Wouldn't be like x minus 2 or something?
what would it have to be?
Oh no, x.
What would it have to be to
Well, we
cancel?
know I would have to be like x plus 2. One
Yeah,
of them has to be x plus 2.
yeah. And so what's the other bracket?
Would it be x minus 2?
So it has to be x, it has to be minus, and when you multiply them, you're left with minus 2. So it would be like last two.
Oh, minus 1. Yeah.
So that has to be minus 1. And simplify.
So it becomes x multiplied by x over plus 2. No, x minus 1 over x cubed.
That's it. So x times x minus 1. Oh, we can make it simpler. Anything else you can simplify?
Can you get rid of the x cubed?
Yeah, we have an x on the top, so that's like x to the 1. So that's now x to the 2.
So it becomes like, yeah.
So it's like there's 3 x's on the bottom. And so now it's x minus 1 over x squared. And that has like plus or minus between them. Can't make it simpler. That one is like times, so you can.
Yeah.
Let me see. Oh, they're getting weird. So they say this is an exam question. That's fair. Oh wait, that simplifies to minus 1. It's just lots of weird stuff there.
Yep.
It's just difference of 2 squares, I think. What would be, how else can you write x squared minus 64?
X plus 8, x minus 8.
How about the other one, 64 minus x squared?
It would be like x minus 8, x plus 8.
I'm not sure. Yeah, I think it is the same. No. The 8 would have to come first, I think.
Oh, okay.
So like 8 minus x, 8 plus x, I think.
Yeah.
So that's, well, those two cancel. X plus 6, x minus 6. I think I see what they're doing here. This one on the, this one down here, I think if you factorize out, very strangely, if you factorize out minus 1, then that changes the signs, and they become the same as up, they become the same as up there, and so you're left with 1 over minus 1, which is just minus 1. All right, I didn't realize it'd be a minus thing. Yeah, so that's difference of 2 squares. It seems to be very common. All right, hang on, that's multiplying and dividing. This is something else. This is, see, they're getting a bit mind-boggling with this stuff, but it's the same idea. Lots of quadratics going on.
Okay.
Let me think about it.
Do we want to work out the one on the left first?
We probably do. Hang on. So let's go with this one. What's the easiest thing to factorize?
We can make x plus 3. Oh no, would it be yeah, it would be plus 3 and then like x times negative 1. For the top right.
So top right, what do they both have in common?
-1 and 3.
Common factor, x squared and 3x.
Or just x?
Alright, what is that?
X minus 3.
How about bottom left? Fully factorize that one.
So can you make it like, could you factorize that too?
Yep, what do you get?
You get x squared plus 5x.
And is there anything that those two have in common?
They have x in common, so they could become x and then x plus 5.
That's it. Okay, and so can we use that to more easily factorize the other two? Let's see. They really didn't. Alright, we better use calculator to the others then.
Okay.
Let's use calculator to factorize top left, let's say.
You get x equals 4 and x equals minus 6, so that becomes x minus 4, x plus 6.
X plus 6. And you'll do something similar for the bottom right. I think you get x plus 6 and x minus 3.
Okay.
And what cancels?
The x plus 6 cancels out.
Anything else?
The x minus 3 and the x minus 3.
And there is one more thing, believe it or not.
The x and the 2x.
Yeah, x and that x there.
Yeah. So now you're left with x minus 4 over x brackets x plus 5.
2 brackets x plus 5.
Oh, right. Okay.
Yeah. Okay, how do we then do part B?
Okay. So could we solve the left as a quadratic and work out like what the brackets are?
How would you go about that? Oh, I see what you're saying.
You'd solve it as a quadratic, yeah.
I think that's the same as the top left one. Let's see.
Oh yeah, it is.
I think all of these, are they? Yeah, it's exactly the same. Well, it's very similar. So it's that times that. Alright. So that's B.
So can we just multiply them together?
So you just multiply them together. So that was x minus 4, x plus 6. And then the other one was x and x minus 3. That's equal to 2 plus the other 2. Alright, how do we go about that?
Okay. So do we just want to multiply the brackets together?
No.
Oh, we want to divide, so we want to get rid of the right or the left, bring it to one side.
So if you bring the ln over, it becomes minus. How do you subtract logarithms?
Do you need to use a e thing?
No. Log rules, to subtract them, you divide.
So we divide by ln.
Subtract. So it is ln of the left one over the right one.
Okay. Oh yeah. Okay. Yeah.
Which ends up being what? The right one was
And then now we can cancel out the x minus 3.
and you end up with exactly the same as the answer for part A. So ln x minus 4 over 2x plus 5 equals 2. And you have to solve that.
So could you multiply by 2x plus 5?
I would put it in exponential form because it's in a logarithm.
So would you do exponential on both sides?
Yeah, what do you get?
Okay. You get, you still got x minus 4 over 2x plus 5, and then would it be e squared?
Well done.
Okay, so it becomes... Oh, just keep it as e squared. You don't want to simplify that.
No, just leave it as e squared. They wanted it in terms of e.
And then would you need to square root both sides?
I would get rid of fraction. Wait, what?
Do you multiply by 2?
They want x.
X plus
5. Let's see. Yeah.
So you multiply by 2x plus 5.
So that is equal to e 2e squared x plus 5.
Yep.
And then you let's see, expand.
Yep.
How do you solve that?
Could you simplify the e squared?
Bring the x's together. Bring the numbers together.
Just so you can divide by x. Does that cancel out the x?
Put the x terms together first. Put the numbers together. So you've got two different x terms. We want one x term. What do you have to do?
Can we use simultaneous equations?
Factorize out x.
Okay.
What do you get?
So you get x and then 2e squared.
X divided by
and then
x.
the other would just be plus 1.
Yeah.
Oh, 1.
And so how do you make it x equals?
Can you divide by the x1 minus 2e squared?
Hold on. Divide both sides by that, and that's your answer.
Yep.
So you have, let's see, you have made it, you've made it x equals. So you found x, and it's in terms of e, so it's an exact value. So if you use if you use calculator, you'll get a decimal. If you put this into your calculator, you'll get the same decimal, but this is the exact value.
Yeah.
I need to consider not using this question because it's quite different. Yeah. Right. Let's see. This seems similar.
Okay.
Yeah, that's similar. I'm just checking. Let's see. Let me see. Yeah, I think you'd be factorize top left, and you can use calculator if you want.
Okay.
Try that.
So for the top, you get brackets x minus 2 brackets x plus a half.
And so how do you deal with x plus a half?
You can make it 2x plus 1.
Yeah. It was x plus a half, was it?
It was minus a half. That was the answer.
Ah.
For it.
And so it's 2x plus 1. Is that what it was?
Yeah.
Yeah, okay. So how about bottom right?
Okay. So you get 3x minus 4
Right.
and positive 6. Just positive 6.
Has to be a bracket.
Oh, wait. Oh, no, it's 6. Oh, no, x minus 6, right?
Let's see. It has to make minus 24. What was the first answer?
It was 3. Wait, no. It was 4 over 3.
So then this one, and the second answer was 6, is it?
Minus 6. So it becomes positive x plus 6, right?
Yeah, then it becomes positive 6, x plus 6.
Yeah.
That's it. Factorize bottom left. What do you get? Simple looking
You
one.
get 2 on the outside. Brackets 3x minus 4.
That's it. And this terrible.
And then the 3x times minus 4 cancel out. The x minus 2 cancels out.
Yeah, well done. You'll be alright. It's just this pretty terrible question. Oh, lie. 2x plus 1. Well, maybe I'm being too hard on it. Over 2. Because in part B, they want you to then expand it. I'm not doing that.
Yeah.
Let's see. Alright, I think we get the idea what these. Yeah. So now let me go back. See the thing. That was in the wrong place. These adding fractions. To move these up. To get all of them. How do we add fractions?
You have to have the two denominators the same.
Yep. We need a common denominator. 2. So that's gonna go there. Hopefully that's all right. Okay. Question. Let's do all 4.
Okay, so for the first one, you need to do 3 multiplied by 4 for both. And you get them both over 12, and then you add them, so it's 4 over 12, and then that becomes 4 over 3.
Not over 3. So first one is 4.
Oh wait, you need to multiply the top as well, don't you? Yeah, it says 4, and then 9 over 3, 9 over 12. And that becomes 13 over 12.
Yeah. Okay, B.
So you get 6x, would it just be 6x both sides?
Yeah.
And then it'll be 3xa and 2xb.
So as one fraction?
It would be. Are you able to add them? Because, like, they're not the same.
You could do that. Well, the denominator is the same.
Then it stays as 6x.
And let me think about this. I'm just seeing something interesting.
Okay.
There's something wrong. Something is wrong. There's no x on the top because we didn't multiply by x. They both have x in common anyway.
Okay.
2x and 3x both have x. That would only be if it was x squared.
Yeah.
All right, question C.
So could you make the right just like x plus 3?
Yeah.
And the top can become also x plus 3.
Bottom will be x plus 1 times x plus 3. So that's your common denominator. Those two multiplied by each other.
Which ones?
Two denominators.
As you get x, also x plus 3 and multiplied by x plus 1. And then the top becomes x plus 1 times 2.
Yeah. What's next?
And then we can simplify.
Simplify.
Oh no, we can divide. So you get 2, so you get rid of the x plus 1s.
It'll go back to being the question then. We did this so that we could bring them together.
Oh, so you get x plus 6 on like the bottom and x plus 2 in brackets.
How did you get x plus 6?
I added the brackets together.
Which brackets?
X plus 3, x plus 3.
Where?
Wait, are we? Oh no, we're minusing, aren't we?
Yeah.
We're subtracting.
Hold on. Here's what you do. Put that in the bracket.
Yep.
And just bring them together first. Over one fraction. And now simplify the top.
The top, so you can cancel out the x plus 3, and so it's just 2 over 1.
Now you have a minus between. You have to expand these brackets on the top.
Okay. So we multiply the two brackets together. Oh no, we can multiply 2 by that bracket, so it gives you 2 plus 2. 2x plus 2.
Yeah. How do you multiply second bracket?
You multiply it by minus 1, so you get minus x plus minus 3. Oh no, minus x minus 3.
Well done. And even simpler on the top.
You get x plus minus 1.
Is that our answer?
And then the x minus 1 cancels out.
What are you left with?
X plus 3.
That's 1 over 1.
Oh, wait. Well, it would just be 1 over x plus 3.
Yeah, 1 over x plus 3. Watch out for that. Okay, that was a good one. Bring together first and then expand. That will help all the minuses to work out. Okay, how about D?
Okay. So it's easy if simplify the bottom right first. So that becomes like x minus 1, x plus 1.
Yeah, that's great.
And then you can bring them together. The whole fraction.
They need to have a common denominator. Denominators aren't the same yet.
Oh yeah. So we could multiply by x plus 1 on both sides. And so it becomes like multiplied by all the other brackets.
Yeah.
you just bring x plus 1 as a bracket on the right, and then on the left it'd be like the two brackets we got on the bottom just brought over to the left.
What do you multiply the top and bottom by on the left fraction so that these two have the same denominator?
X squared minus 1.
Sure. So the denominator on the right is x plus 1, x minus 1. What do you have to multiply the denominator on the left by so that they have the same denominator?
X plus 1.
It already has x plus 1.
X minus 1.
Now they're the same. X plus 1, x minus 1. To keep the fraction the same, whatever you do to the top, you do to the bottom.
Okay.
Now they have the same denominator. Okay, what's next?
Then you can bring it to make one fraction.
Well done. Go on.
And then the x minus 1 cancels out.
Sure it doesn't. Plus or minus between.
Oh, yeah. So you multiply by the 3 on the bracket, which gives you 3x minus 3, and then you also get you make it. Could you factorize out 1 minus 1?
Don't worry about that. Just simplify.
And you get minus x minus 3.
Minus x minus 3. So if we had maybe an x plus 3 on the bottom, we would start factorizing at minus 1, but we don't, so that's it. That's fine. Yeah. So, yeah, to get the denominators to be the same, you have to times the other one by minus 1 and do the same to the top.
Yep.
To keep it equal.
Yep.
Let me see this. Yep. Right as a single fraction. You'll be alright. Right as a single fraction. Looks good. Maybe just do exam stuff. Hang on, so that was 1, 2, 3, 4. So 3 is there. That looks interesting. And then 4. Alright. Wait, is that a times? No, it's minus. That's a minus. Let's see these. Alright, I wanna actually here. What would be question B?
Okay. So would you make it like x plus 2, x minus 2?
Yeah.
And then you can bring the fraction together.
They need a common denominator first.
It'd be x minus 2.
Yeah.
Multiply by x minus 2.
And on the top, same thing.
Yep.
And then?
And then you can bring it up as one fraction.
Yeah.
The top becomes 3x minus 2. And that simplifies down to 5 plus 3x.
X, that's over the denominator. Alright.
Yep.
So this one. Yeah, how about this?
Okay. So you can. It's easier if we solve the bottom as a quadratic first.
Okay.
And you get x equals 3, so it becomes x minus 3, and x minus equals minus 5, so it becomes x plus 5.
X minus 3, x plus 5.
Yep.
X minus 3, okay.
And then we want a common denominator, so you make it so it's multiplied by x plus 5. Am I right?
Yeah, so what does the fraction become?
It becomes the same as the one on the left.
What does? The denominator?
The denominator. Oh no, the top becomes x plus 5 as well, like multiplied by x plus 5.
Yeah, that's it. Times sum bottom by x plus 5. And then you bring them together and you do all the stuff.
Yeah.
Let me see. I think that... So now question C.
Yep.
Let me copy that. Let me copy this whole page actually.
Okay.
So I have the answers. Copy. Yeah. Okay, question C.
So you'd solve both bottom and top, bottom by quadratics.
Yeah. What do you get?
Okay. So for the bottom left, you get as brackets x plus 3 and wait no, x plus 3. It's the only one. It's just x plus 3.
So that's kind of weird. Then this one is x plus 3, x plus 1. So how do we get a common denominator?
Oh no, as in like the one in the bottom left is just x plus 3 as a bracket. There's no other bracket.
So then it has to be the same bracket twice. So the calculator just showed you
okay.
the one answer.
Yeah. Yeah.
Okay. That's weird. Alright, how do we get common denominator?
We multiply by x plus 1 on the left.
And how about on the right?
You multiply by x plus 3.
I think so. X plus 3. And then you just bring them together. Oh, that's a strange one.
Yep.
What is E? So I think that's 3 over x plus 1, x plus 2. That's minus 1 over x plus 2, x plus 2. These questions, why do they have to be weird? No, it's the same idea. Hold on.
Okay.
F. Just looking for some normal one. I don't like that repeated thing. Like, just give me a normal one. Even this one, like, you have to be weird about it.
Yeah.
X minus 4, x plus 3. Why? X plus 2. That's it. It's a good one. That's almost good one. Yeah. All right. How do we do this?
So we multiply the right by x minus 4. And multiply the left by x plus 2.
Well done. All right. Hold on. Let me put that there. Hang on. Even better. What is that? Put it there. Do that. And then change that to like that or something. Just keep it simple. All right. There we go. That has weird stuff. E D C weird.
Yep.
Square bracket. So I don't waste my time again with those questions.
Yep.
Like, there's no need for them to do like the same thing twice. X plus 2, x plus 3. Like,
Yeah.
All right. Common denominator for A.
So would you want to multiply each denominator by each like other denominator?
Yeah.
So it's like, so if you do the first two, it's easy if we just forget about the one on the right.
Yep.
So we can just make it x plus x multiplied by x plus 1 and 3 multiplied by x plus 1. And on the right would be x multiplied by x plus 1 and x multiplied by 2.
What will be the overall common denominator for all three?
X.
I know. It will be all three multiplied together. So
what do you mean by what's the most common denominator?
The common denominator would be that. So.
Oh yeah. If it was all of them, yeah.
All right. And so what's the middle one?
Pardon?
So middle one?
Oh, the middle one, it'd be 2 multiplied by x, 2 multiplied by x plus 2. And the bottom would be x plus 1 multiplied by x, then multiplied by x plus 2.
And right one?
1 multiplied by x, 1 multiplied by x plus 1. And then over the same again.
Yeah.
Yeah.
And so that one. Yeah. So they already have one piece of the puzzle each, and so you have to multiply by the other two.
Yep.
And then we bring the whole thing together, and it's gonna be good. Right. How about the last one, question C?
So you make it the fraction on the bottom, well, the fraction on the left would become, the top would become 3 multiplied by x plus 1 multiplied by x minus 3. And then the bottom would become x minus 1 multiplied by x plus 1 multiplied by x minus 3.
All right, so that's the common denominator. So what's the numerator for the middle one?
2 multiplied by x minus 1 multiplied by x minus 3.
And top right?
4 multiplied by x minus 1 multiplied by x plus 1.
I just brought them all together so I didn't have to repeat that thing.
Yep.
Plus 1. And then you have to do a lot of expanding, a lot of simplifying, yep. But it boils down in the end. Let's see. All right. Any idea about this one?
Okay. So would we want to simplify it first?
Okay.
So you get 6x minus 4 on the top left.
8x minus 4?
Oh, so yeah, 8x minus 1, then minus 4.
All right.
And then the bottom, would you simplify that as like a quadratic? Would that work?
Yep.
Okay. And you get x is either 1 over 6 or minus 1 over 6. Right. So you get x is minus 6 or minus x is, so you do x minus 1 over 6 times 1. X minus 1 over 6 and then x plus 1 over 6 in brackets.
Hold on. All right. So x minus a sixth, x plus a sixth. But,
yeah.
But they can't be fractions. They have to be whole numbers.
So it'd be 6x minus 1 and 6x plus 1.
Yeah. What's next?
And then you can bring the fractions together.
They don't both have a common denominator.
Oh, see, yeah, so the top left becomes 8x minus 1 minus 4 multiplied by 6x minus 1.
The top left already has a good denominator. It's the top right that's missing.
So you just multiply by 6x plus 1.
Yeah, to the top and bottom.
Yeah.
Now they have the same denominator.
Yep.
Now you can bring them together and do all that stuff. Let's see this.
Yep.
Alright. So what would happen to the one on the right for this one?
So you can solve as a quadratic first.
So that denominator there, that's 36. That is x minus 4 and x plus 2.
Okay, yep. And then you want to multiply the top right by x plus 2. So it becomes like 36 times x plus 2.
That already has x plus 2 in its denominator. So we don't need
so you only need to do the right then. The left, sorry. So you do x minus 4 multiplied by it.
So let's say the
so
middle.
You have 6
yeah.
multiplied by x minus 4. And then x plus 2 multiplied by x minus 4.
Yeah. And top left.
That becomes x multiplied by x minus 4 and x plus 2.
Over
1, right? Oh no, would it be over 1?
It was over 1, but to keep the...
Oh, you want to multiply the so you get x minus 4 and x plus 3.
Plus 2?
Plus 2, yeah, sorry.
That's it. So the right one, you didn't need to multiply by anything. The middle one,
yep.
You had to multiply the top and bottom by x minus 4. And the left one, you had to multiply by both.
Yep.
Okay. Fine. Let's see this. So let me see. That same idea. I think it's good. I'm missing the answer for 8. Am I? Let's see. Let's see. So 9 is 3 things. You bring them together. Yeah. Any idea how they did part B? They did this part A. The f of x is this x cubed thing. And then they said, sure, they can be simplified even further. Any idea how they went about that?
Did they cancel out like the bottom, like instead of adding, they cancelled out the brackets?
So they cancelled out the x plus 3 bracket. But how did they wind up with this?
Did they? I don't know.
You can use your calculator to solve the cubic on the top.
Okay.
So degree 3, 1 minus 2 minus 10 and 15. So we get minus 3. So one bracket is going to be x plus 3.
Yep.
Oh, that doesn't work. I don't like that. We get something weird. I know.
Yep.
On the bottom, we had x plus 3.
Yep.
And x minus 5. What would the second bracket have to be? On the top? So that we end up...
X... Oh, would we just see... Wait, it would just be x cubed, x squared minus 5 plus 5. Minus 5x plus 5, yeah.
Yeah, because they gave us that so we could see it. And so
and then the x plus 3 cancel out, yeah.
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 Hey, that's good. Okay, so that's that stuff. We got it. So what do you give yourself for algebraic fractions?
A tick. It's really good.
Well, it's going to get really bad. Trust me on that. They're not all this normal.
Was this like the easiest topic?
It's pretty easy because it feels like normal kind of maths, you know.
Yeah.
But
Yeah.
later on, you're just looking at it and you're like, what even is this?
Yeah.
So next topic next time.
Yeah. What is the next topic?
It's partial fractions, and so it is
Okay.
the opposite of this. They'll give you the answer, and they'll say, find out what two
Oh,
fractions
okay.
were added.
Yep.
Any questions in general?
No.
All right. Well done, Adam. You did great, and
Thank you.
have a nice weekend. And talk to you next time.
You too.
All
See
right.
you later.
Take care. Bye bye.
Bye.